Hi, welcome back. This is the third video in the Calculus AB topics review. And in this video, we're going to look at derivative rules. So this is very important, very essential to understand for the entire course. And there's four basic rules that you need to know, and they're all relatively easy to understand. So first you have the power rule, then the product rule, then the quotient rule, and then the chain rule. And I'll go through a quick example of each of these. But outside of those four, you also need to memorize some trig derivatives, logarithmic derivatives, and exponential derivatives. So at the end of the video, I'll go through some of those that you need to know. So first, let's look at the power rule. So if you have a function like this function here, where you have a coefficient times x times a variable to the power of e, when you take the derivative of this function, it's going to be the coefficient. That coefficient could be 1, 2, 3, 4, anything, times the exponent times x, or whatever variable it is, to the power of the original exponent minus 1. And another way to write this, another way that's commonly written, is if you have a function f of x that's equal to x to the power of n, take the derivative of this function f of x, you're going to end up with n, right, the exponent, times the variable to the power of n minus 1. So it's the same thing I've written over here, but just to clear up some confusion, it's important to remember that if you have a coefficient, you're multiplying the exponent by the coefficient. Okay, next let's look at the product rule. So if you have a function like h of x that is the product of two other functions, for example f and g, the derivative of h of x is f prime times g plus f times g prime. So what this looks like in practice is if you're asked to take the derivative of a function, for example, 3x squared minus 2 times 4x squared plus 3. So this is our h of x, and each of these functions are either f or g. So for example, this could be f and this could be g. So since they're being multiplied by each other, we know to use the product rule. So first we're going to find the derivative of f, and that comes out to 6x, right, based on the power rule. And also, to touch on this quickly, whenever you take the derivative of a constant, it's just 0. So 6x times g as it is, so 4x squared plus 3. And then we're going to add that to f as it is, so 3x squared minus 2 times the derivative of g, which is just 8x, because 2 times 4 is 8, and then x to the power of 2 minus 1 is x to the power of 1. So this would be our final answer based on using the product rule. Okay, next we have the quotient rule. So our new h of x function is f of x over g of x. And in taking the derivative of h of x, we have to find f prime of x, multiply it by g of x, and then subtract f of x times g prime of x. So it's similar to our product rule, except we're subtracting this time. And then another difference is that we're placing all of that over g of x squared. So what that looks like in practice is something like this. If we have a function, we'll call it h of x. If we have a function h of x that is 3x squared minus 2 over 4x squared plus 8, what we need to do is first find the derivative of, we'll call this top part f and this bottom part g. So first we need to find the derivative of f, which is going to be 6x, and then multiply it by g as it is, and then subtract f as it is times the derivative of g, which is just 8x. And then we're going to place that all over g squared, so that would be 4x squared plus 8 squared. So we're not taking the derivative of g again on the bottom, we're just keeping it as it is and squaring it. So that's what the quotient rule looks like in practice. So now we have the chain rule. So if we have a function h of x that looks like this, f of g of x, so it's one function inside of another, to find the derivative of that h of x function, we're going to first take the derivative of the outside function. So we're going to have f prime of g of x, and then we're going to multiply that by the derivative of this inside function. So multiply it by g prime of x. And this can go on for as long as it needs to, as big as the chain is. You may have something like z of f of g of p of q of x, however many parentheses I need. And to do something like this, you're just going to take the derivative of the outside. So you're going to have z prime of f of g of p of q of x times f prime of, and then you just continue down the chain until you get to the innermost function. So now let's see what it looks like in practice. So if we have a function like f of x equals 9x cubed minus 8x plus 4 to the power of 5, and we try to take the derivative of it just using the power rule, we're going to end up with 5 times 9x cubed minus 8x plus 4 to the power of 4, right, based on the power rule. But that's wrong because we've left this whole inside portion of the function as it is. It hasn't been derived. So what we need to do is apply the chain rule. So first we're going to take the derivative of the outer function like we just did. So let me write f prime of x equals. So the derivative of the outer function can be found using the power rule. So we're going to multiply 5 times this coefficient of 1, so 5 times 9x cubed minus 8x plus 4 to the power of 4, right? 5 minus 1. And then we're going to multiply that by the derivative of the inside function. So that would be 27x squared minus 8, and that's it. So by applying the chain rule and to take the derivative of this function, we end up with this new function, f prime of x. So here's a quick list from UC Davis of all the extra Calc 1 derivatives that you need to memorize. So I recommend making flashcards or something like that to memorize the rest of these, and that should make your time in the class a lot easier. I think that making flashcards to just memorize things is one of the most important things you can do to be successful in this class. That's what I did, and it made the class a lot easier for me.